Hi everyone, so now we're going to talk about how we can use proportions to solve similar shapes or determine if shapes are similar. So similar shapes will look the same, have the same angles, but maybe be bigger or smaller than one another. So that's different than congruent shapes, and we'll talk about congruent shapes in another video, but similar shapes can be bigger or smaller than each other, but have the same proportions, where congruent shapes are exactly the same. So in order to determine if something is similar or not, what we have to do is set up some proportions that compare the two shapes, and if those proportions are equal to each other, then the shapes are similar. So the way that I like to do this, for the first two examples, what we're going to do is decide if the shapes are similar or not. And the way that I like to do this is I like to compare side to side. So I'm going to start with maybe the tops of each of these shapes. So I'm going to do them in a different color. So let's say the top of this shape is red, right? And that's 28. We know that. And then the top of the shape on the bottom is also, we're going to call it also red, which is 21. Then let's compare that to maybe the right side of the shape. So let's make the right sides of each shape blue, which gives you 16 on the top shape, and then on the bottom shape we have 12. Okay, so now what we're going to do is set up two fractions. We're going to set up a red fraction and a blue fraction and decide if they are equal to each other. So for the red fraction, I'm going to do the top shape over the bottom shape. We have to set up a fraction, and you have to decide if it's going to be like the bigger shape over the smaller shape, or the top shape over the bottom shape, left shape over the right shape. It doesn't matter as long as you remember what's going to happen. So what I'm going to do for my proportions is I'm going to say it's got to be the top shape over the bottom shape. All right, so my red fraction would be 28, because that's the top shape, over 21, because that's the bottom shape. And then my blue fraction would be 16 over 12. Okay, so now what we're going to do is simplify both of those things and decide, or actually we'll just plug them into a calculator and decide if they give us the same answer. So I'm going to plug in 28 divided by 21 into a calculator, and what that gives me is 1.3 repeating, so 1.3333. Now I'm going to plug in 16 over 12, which also gives me 1.3 repeating. So because these two things are equal, that means that these two fractions are equal, and because those two fractions are equal, that means that the proportions are equal, which means the shapes are similar. So I can say that these two shapes are similar. Sweet. Okay, so now let's go over the second example. We're going to do the same thing. I'm going to once again use those proportions top over bottom. And now we just have to figure out like red versus blue. I'm going to do the red as the tops. So we've got 10 and 13. And then let's do blues as the side lengths again. So 9.5 and 17.4. Okay, so once again, we're going to set up our two fractions. Our red fraction, because it's top over bottom, would be 10 over 13. And then our blue fraction would be 9.5 over 17.4. Okay, so now we're going to just plug those into a calculator. When I do 10 divided by 13, I get 0.7692. And when I do 9.5 divided by 17.4, I get 0.54598. And those are both rounded. Are those two things equal to each other? No, because one's 0.7 and one's 0.5. So these two things are not equal to each other. Because they're not equal to each other, that means that these two things aren't equal to each other, which means that the shapes are not similar. They have to be exactly the same in order to be similar. All right, so now for the next two examples, what we're going to do is assume that the two shapes are similar and set up proportions to solve for x. So we're going to do it really similarly. What I'm going to do is, this time we're going to do, because they're on the sides of each other, I'll do the left shape over the right shape. And when we set up proportions, obviously on this one, we've been given all three sides, which is great. but we want to solve that for x. So we know that one of our sides has to be this side, because on the second shape, that side is the thing with the x, which is what we want to solve for. So we're going to make our red fraction the left side of the triangle. And then for the blue fraction, it doesn't matter if we do the bottom or the side or the other side. We'll just do the right side. So it'll be 8 and 4. Okay, so now when we set up these proportions, it's left and right, which means that our red fraction will be 10 over 2x minus 9, and then our blue fraction will be 8 over 4. And remember, we've decided that these shapes are similar, and so because they're similar, these fractions are equal to each other. And now we're going to go back to that last video. When we have two fractions that are set equal to each other, we can cross multiply and solve. So the first cross multiplication would be 10 times 4. And then the second would be 8 times 2x minus 9. You got to remember to put that 2x minus 9 in parentheses so that 8 can get to all of them. Once again, the fractions cancel out, so now we can just simplify and solve. We have 10 times 4 on the left side, which gives us 40. And then on the right side, we're going to distribute the 8, which would 8 times 2x gives me 16x, and 8 times negative 9 gives me negative 72. Now we're solved for x, so I'm going to add 72 to each side to get the x by itself. And we get 112 is equal to 16x, and then we're going to divide each side by 16 to get the x by itself. I'm going to move my stuff over here just so we don't run into the last problem, and I would end up with x is equal to 7, and that's our answer. Okay, awesome. So now let's go through this last example. On this last example, once again, let's do top over bottom. This is really important that you recognize, or that you kind of set this up for yourself. You don't have to write it out top over bottom or left over right. Just make sure that you remember it, because if you switch one of them, or like one of them is top over bottom and the other one is bottom over top, it will not work. It doesn't make sense. So we're going to do top over bottom on this one. And in this case, the bottom shape has 3 numbers, but the top shape only has 2. Or 3 sides, and then the top shape only has 2 sides. So we have to use the 2 sides that we were given on the top shape. So let's make our red the right side, which would be 12 and 2x minus 14. And then we'll make our blue the bottoms, which are 21 and 14. And so they gave you that 14 on the top. We don't necessarily need to use that, because we already have enough. We only need 2 sides. So our first fraction, top over bottom, would be 12 over 2x minus 14. And then our second fraction, which is blue, would be 21 over 14. Okay, so because they are similar, they told us they're similar, we're going to set these things equal to each other, and then we can cross multiply. When we cross multiply, we're going to have 12 times 14 on one side, and then on the other side, we're going to have 21 times 2x minus 14. We're going to set those things equal to each other and then simplify. So 12 times 14 gives me 168 on the left side, and then we're going to distribute the 21 inside this set of parentheses. We have 21 times 2x gives me 42x, and then 21 times negative 14 would give me negative 294. All right, so now solving for x. The first thing I'm going to do is add 294 to each side. The 294s cancel out on the right side, and we're just left with 42x. And then on the right side, we have 196 plus 294, which gives me 462. And then we want to get x by itself, so we've got to move that 42. We're going to divide by 42 on each side. And 462 divided by 42 gives me 11, so that's 11. 42 cancel out over here. We get x, which means that 11 is x. And there we have it, how to solve similar shapes or decide if shapes are similar.